Hello everyone, myself Swapnil Futane from EP2, and here's my project presentation. And my project is based on machine learning based event driven price forecasting. So what we are gonna basically do is we are gonna try to predict price movements after event announcements on Forex Factory. So Forex Factory is a basically economic calendar on which there are events announced beforehand, and the values of events are announced on the particular time, and that values causes significant impact in live markets, and that we are trying to get a relationship between the live market movements and the impact and the events. So what we are basically gonna do is predicting short-term EUR USD price impact after economic news. So, why studied event-driven price movements? So, the first question we have to answer is why do we have to study event-driven price movements? So, the as you know, I have answered this in a bit before. Forex market exhibits sharp reaction to major economic announcements, creating opportunity for quantitative analysis. So, the events are whenever the events are announced, we get a sharp reaction based on the magnitude of the event, and with that we can get a good quantitative analysis to know how much price change can happen in future for the similar events. Magnitude of price impact correlates with event importance and forecast surprise magnitude. So that's what I was telling. And traditional manual observation of this pattern is time consuming and prone to subjective bias. We just seeing because last time the price happened to move up because of the event, that's very subjective and very time consuming to check all the patterns and all the previous data of different currency pairs. That's where the machine learning offers a systematic approach to quantify and predict this market response with measurable accuracy. So that's why we are gonna I'm pursuing this project. So our project objectives are build ML prototype. The first and the most important thing we are gonna do is build a ML prototype, which is where we'll develop a regression model to forecast pip movement magnitude following high impact economic events. So the goal is to get the price movement of how much pips would be the price movement following the magnitude high impact event which is going to occur in the future based on previous data set. And for this we'll need to have data from various sources, and that sources would be we first need to have economic calendar data which we'll get from Forex Factory, and the second data set will be the OLHC data set, which is basically the live data set of markets which are giving the reactions on the economic news. And the third project objective is we have to basically get the short-term prediction with the predict volatility magnitude within 15-minute window post announcement of actionable insights. So we'll start with the first basic thing of data collection architecture. So as I have already discussed, we'll need two things, that is economic calendar data and the OLHC data set. So economic calendar data will get from Forex Factory News because that is the gold standard in the industry, and on that we have almost every news which has to be covered in global markets. So we'll extract the Forex Factory weekly data using Selenium Web Scraper, and then it will be stored in a CSV file having date, time, country, impact level, forecast, and previous values, which is focused on, and we'll try to focus on high impact economic calendars. And we have the code here where this is the code for our data extraction in uh, for Forex Factory, and will scrap the data and store it in a CSV format. And as you can see, with this data, with this code, we have generated this type of CSV file, where we have title, country, date, time, impact, forecast, and previous with the URL of the Forex Factory. So this is how we are gonna generate our Forex Factory news CSV. And the next thing we'll need is the reaction from the markets. And how do we get the reactions from the market? We have the OLHC candlestick data pattern. What is OLHC? OLHC is open, high, low, and close. That's how the data is represented in market. And we will get this OLHC candlestick data for 5 minute time frame so that we can get the accurate picture of what happened just next to the event. And how are we gonna extract this? We are gonna use Y Finance. With help of Y Finance, we are gonna extract data for different kind of forex pairs, and we'll store that data also in CSV format. So as I can show you, we have our market OLHC and forex OLHC. This is our code for data, like market data extraction for OLHC candle patterns. And for now we are extracting, we have extracted different types of pairs, and this is how the data looks like, where we have time, the open, high, low, close, and volume. So with this help of two codes, we have our initial stage done, where we have collected the data, and now we are moving on to the next stage where we'll pre-process the data. And for the data pre-processing, we have three main tasks. We have to first timestamp unification. What that means is we have to convert all timestamps to UTC and filter for EUR relevant events to ensure temporal accuracy. So what this means is the events and the OLHC data which we extracted was in IST time frame. But when we have to connect it with the broker and execute the trades in real time, the broker server is in UTC time. So that time mismatch would lead to very different outcome, and we don't want that kind of disturbance. So what we will do is convert our all data from IST time frame to UTC time frame. And for this project, we are focusing on EUR USD. So we'll filter for EUR relevant events, and so that we can easily have our data pre-processed and use for our next ML model. And the second task for our data pre-processing is impact encoding. So as you can see, as I can show you that the forex calendar data was given as title, country, date, time, impact, and in this impact, see, you can see that it's written as low, high, or medium. So that's very descriptive, and we have to give it a numerically, we have to encode it numerically so that we can use it in our ML algorithm. So we'll assign high equal to 3, medium equal to 2, and low equal to 1 for model compatibility. And the third pre-processing task we have to do is feature engineering. We basically have two features, and that two features are calculated surprise metric. The surprise metric is the forecasted value minus previous value. So that is the forecasted value which was basically forecasted by economic events on the forex factory before the event was released, and the previous value is the release time, released actual value, and the surprise factor is the difference between these two values. And then we will see the pip move, absolute 15-minute price change corresponding to this time, this exact time frame for the EUR USD currency forex pair. So we have this data pre-processing, we have this code for data pre-processing, and this code ensures all our three tasks are to be done: time unification, impact encoding, and feature engineering. With this code, we have pre-processed our data and stored it in a CSV. Now we'll move to the third and most important aspect of this whole project, which is machine learning model architecture, where I have used random forest regressor selected for its ability to capture non-linear market reaction and provide interpretable features importance. Ensemble approach. So as we have small data set to work on, we have to use ensemble approach so that we can maintain the robustness on while maintaining the prediction accuracy. So what we have for input features is impact level, forecast value, previous value, and surprise magnitude. And what we are expecting for output values are predicted pip movement. And as we can see, we have our ML model here, and this is our ML model where we get the CSV and we do the ML regression where and we try to get the output of predicted pip movement. And with that, this code, we give it the basic input features and we get our desired output. And after performing the ML regression model and getting our data, the first thing was what data split I used. 80-20 data split was used, 80% for training set and 20% for testing set, with standard scalar normalization applied to all features. And with this data split, the, the results were quite useful, and we have got this as a table where we have impact level, forecast, previous, actual pips, and predicted pips. This is our CSV for predicted prediction outputs, and with this you can see we have calculated the performance metrics for this total data, and we got the R square equal to 0.296 and mean absolute error equal to 1.833 pips, which means that we have approximately 30% of capturing 30% of price variation. And this is something how the graph looks like. And key insights from the model analysis, what key insights we got from this model analysis is impact level dominance. The impact level emerged as the strongest predictor for price movement, confirming that high impact event systematically generate larger market reaction. So this is what we have been predicting, and we were wanted to confirm that the high impact events which were given numerically in assigned equal to 3, that were the events which systematically generated the largest market reactions. And then the next thing which was having the most amount of most amount of reaction was surprise factor. So surprise factor is basically what we discussed. It was pre forecast minus previous, and for the surprise factor, the larger the surprise factor was, the more we get the reaction and the more we have larger market reaction. And forecast and previous values contributed smaller weights to prediction, suggesting market participants focus more on event magnitude than specific values. And also pattern recognition success. Random forest effectively learn non-linear relationship between economic events and currency pair volatility without overfitting. And this is how we have our project where the surprise factor and impact level are the two most important things which have the largest reaction in the market. And now we'll come to the limitations and future research directions on this project. The current limitations are limited data scope, analysis restricted to EUR USD. For now, we have restricted our analysis to one currency forex pair, which is EUR USD, with only 1 week of observation and limiting generalization capability. So, at a time, I can scrap up to 1 week of data, which is a little small amount of data for having a good price prediction, which is limiting my generalization capability. And the second limitation is latency constraints. So as you can see, this data is in CSV form, which is in OLHC form. But the OLHC data is not a real-time execution data. There are latency issues where the prices at the high economic event, the prices move very fast and the latency is huge, and there is a spreads and swaps and commissions which are not yet accounted into the code, so that we will try to account them in the future enhancements. And now we'll come up to future enhancement. We have multi-pair expansion. We'll try to extend our analysis to different type of pairs, forex pairs, such as GBP USD, USD JPY, and XAU USD for cross market validation. And we'll try to real time integrate this using APIs of different brokers such as MetaTrader 5 or Wanda for production ready implementation. And as we have more and more amount of data set, we'll try to have advanced algorithms which such as XGBoost and LSTM networks to capture temporal dependency and improve accuracy. So this is it about my project, and the key takeaways for this project was we were successfully able to build and validate a machine learning model for event driven forex price forecasting with practical applicability. And we have effectively combined fundamental economic news data with high frequency technical market data for comprehensive analysis, and we have got a meaningful accuracy for a prototype model, which is r square equal to 0.296 and MAE equal to 1.83. So that's it from my side. Thank you.